Hi, so let's try to understand how to implement an LRU cache. Before we try to implement an LRU cache, we need to understand what is a cache and what is LRU. So
A few minutes later.
hi, do not skip this video because this is very important video. It is going to remain as one of the basic concepts when we do designing at large scale. For system designing, LRU cache is something which is very important. Today we'll see how to design an LRU cache.
A few minutes later.
LRU cache is nothing but a cache with LRU as eviction policy, which is least recently used. So it is typically a cache where we remove the value which is least recently used first. And this is an important question from interviews perspective because this is commonly asked. I have seen candidates reporting in that this question is generally asked in interviews from Amazon, Microsoft, and typical startups like Flipkart as well. So this is primarily asked with candidates who are coming in for SD1 and SD2 because this as a question is very basic information that one expects the candidate. This is one question which helps us decide whether we understand the basics of cache and the eviction policies or not. So please pay attention. In this video, I'll show you both how LRU cache works and an example code. Plus, I'll also have the link to the code in the description box so that you can utilize this.
A few minutes later.
Hi, so let's try to understand how to implement an LRU cache. Before we try to implement an LRU cache, we need to understand what is a cache and what is LRU. So in order to understand cache, understand it this way that cache is something like a memory from which data can be accessed way faster than the same can be done from, let's say, a hard disk drive, some sort of storage or database. So what really happens is first time when we get this data, we try to keep a copy into cache, and then if there is any consecutive or any other request for this data in near future, we see if that copy is available into cache, and we try to serve that request from the cache itself. We also need to understand that when we do it, cache here is working as like an intermediate layer which stores data to speed up the ask for the same data in near future. What does that mean is, for example, if I have a function which does some recursive operation which is taking, let's say, 10 seconds per operation, and this operation is heavily dependent on the sort of input which is needed and the output is totally dependent on it. In that case, we can do it in this way that, let's say, if the input is A, we perform the calculation, serve the calculation back to the request, and then store a copy of the response into the cache. Now next time when somebody asks for the output for the same input, we see if the input is available into cache, and then we serve the request from the cache itself. So this is nothing but cache. In order to understand LRU, so LRU is nothing but a cache eviction policy. LRU stands for least recently used. When we try to understand what is a cache eviction policy, we need to understand that cache, because it is serving request in a smaller period of time, hence it is preferred. But the idea about designing a cache or using a cache always is that the cache has a limited number of memory, and it is generally costly. So you cannot have an unlimited sort of storage. For instance, you can have a cache of, let's say, 20% of what the actual storage is in terms of database or in terms of hard drive. So a cache generally is considered as good as the eviction policy. So eviction policy is nothing but when the cache is full, what is that data that can be removed from cache in order to store the new data into cache. So I'll give you an example. So one of the easiest policy to understand is FIFO, which is first in first out. So for instance, if the size of our cache is 4, request 1, 2, 3, 4 comes, and let's say if there is another request after this 4 which is 5 which comes in, then we evict the first one, which is the first. So this is nothing but FIFO. Similarly, there are other algorithms for eviction like FIFO, LIFO. LIFO is last in first out. I hope you guys already know this. And in order to design a cache which is performing better, then it is LRU or least recently used. In this, what we do is we simply remove the data which was not used recently, or the data when compared to other data which is used recently. So I'll give you an example. Consider this example. So we have a cache. The size of cache for simplicity is 3. There is one request which comes, that's called A. So cache, the size of cache is right now 3, and it is all free. So A is stored into the cache at the first position. Then there is another request B which comes. Since we already have free space available into the cache, we store it in the cache. Then let's say if there is another operation C, then C also gets stored into the cache. Now understand this. If the fourth request D comes, then we need to get this D into the cache, and something has to be removed because this cache is already full, and in this case it is going to be A. Why? Because this is the least recently used. This was the request that came in when you sorted by time, then this was the request which came the first. And then let's say if there is another request which comes for C, then C is served from cache because it is available in cache, but remember the order will also change. Now C is the current use, and D and B are in order of least recently used. Now B still is least recently used, but D and C gets interchanged because C is the one which is being requested. So we need to maintain the order as well, so that we know what is the order in which we need to evict. So eviction generally happens from the back of cache, and entry is from the front of cache. So this we have to keep in mind while designing a cache. Similarly, if there is another request that E comes, then in this case what will happen is when E comes, C will be there. This is going to be D, guys. This is D, and D will be evicted. So you understood the cache, right? How does that work? Now let's try to see what are other requirements which should be considered. So what are the deciding factors when we try to consider the data structures that we need to use? One, understand the requirement. The lookup for a value into cache and the removal should be for fast operations. When I say fast, it should be almost instantaneous or fixed time operations, which means that get operation and put operation from the cache should work in O of 1, which is constant time. Whenever somebody says that we need an O of 1, the first data structure that comes into my mind is a hash table. Why hash table? Because if we have to see if there is a key which exists into a hash table, then it is O of 1. And now, do you remember, we need to store the data which is coming in order. So for maintaining this order, the data structure that can fit into our requirement is doubly linked list. Doubly linked list, why? Because in double A linked list, we have pointer to the first node and the last node, or let's say head or tail, and removing a node from mid, or let's say changing the order, is very simple because every node has address of the previous node and the next coming node if there is any into the data structure. So hence this is how we try to decide what are the data structures that needs to be used while designing a least recently used cache.
2 hours later.
Now let's see how the code will work for this. So what we have done here is we have created a class node, and this is the key, this is the value. So understand it this way, that when we are storing these values, these are just the keys, and then the response also will be stored. So for this means is A is the key which is being requested, and what is the response that needs to be provided, right? Because incoming request will have a key, and then response should be the value of it. That is what we store into the hash table. So this is the simple class, the data structure which we are going to use. One is in this case we are using int, so the value and key both are int type, and we are also maintaining node of previous and next. This is the simple constructor that we are going to use with a key and a value which initializes the key and value. Now this is the main class, which is LRU cache. So what we have done is we have declared a capacity here, which we are going to initialize using the constructor. Then there is a hash map. So hash map of int and node, which means that for the incoming value we'll store the node itself, so that the get operation is faster. And then we'll also maintain head and end, of course, because we need to do the operations from head and end. So any incoming node will come at head, and any node that needs to go out goes from end. So this is the constructor for the LRU cache. End capacity, initialize the capacity. Now this is the get operation. What happens when somebody tries to see if there is a value which if it is there in the LRU cache, then it should return, otherwise it should return, let's say, -1. So what we are doing is we check if the map contains this key. Yes, if it is there in our cache, then we get the node and return the value of the node. And before we do that, we do two operations, which is delete this node and set it to head. So this is the change of order. So if somebody is accessing this becomes the most recently used value, which we need to set at the starting of the cache. And if it is not there, just simply return -1. This is the get operation. Now, how does the delete and set head that we used here looks like? So delete, what it does is, if the node which is to be deleted has a previous node, then what we are doing is previous is next is pointed to nodes next, which means if it is from between, we just remove it. Otherwise, what we are doing is we are setting head as nodes next, which means that if previous is null, that means it is the head, right? So in this case, we just set head to the next. If node of next is not null, which means there is a value which is there after this node as well. So what we do is nodes next previous points to nodes previous. This is the back, like when we have a doubly linked list. In this is the reverse linking which is there, and we set end to node of previous. Similarly, what happens when we do a set head? So set head you might have seen. So set head does nothing but sets the node which we are like inputting as head. Previous, of course, for the head will always be null, and if head was not null, then head's previous becomes the node and head becomes the node. And if it is like if the end of this is null, then end also becomes head. So this is the case if in case where there is only one node. Similarly, for set, there is an int key and int value. We check. So when does set calls? If there is any value that we need to store into the cache. So now there can be two scenarios here. One, this is already there, and otherwise second scenario where it is not there. So if map contains the key, what we does is we set old, like we fetch the old node from the hash map that we have, and we set old's value as value, delete the old and set the old as head. Otherwise what we do is we create a node because it's not there. Now this is important. So see, if we are over capacity, then we remove the end, delete the end and set the head as new node. Otherwise we simply set it here, and then we also put a value into the map. Thanks guys, I hope you liked the video, and in case if you liked it, please do not forget to subscribe and share it among the friends, because this can be very important for anyone and everyone who's like studying for an interview which is upcoming.